In today's video, we're going to be looking at about 5 different scenarios where we are going to draw free body diagrams from each of these scenarios. To draw a free body diagram, you basically treat the object as if it were a dot. So for us, we're just going to draw a little dot, and this dot is going to represent our car. And a free body diagram is going to have an arrow that's coming off of the object that represents a force that's acting on this object. So if a car is moving to the right and slowing down, the force would be the brakes, and the brakes are going in the opposite direction of motion. So we are going to draw an arrow in the opposite direction of motion, and we are going to label this the force of the brakes, or the stopping force, or whatever else you want to call it. Now we also have to have the force of gravity, because this car is sitting here on Earth, and the road also provides something called the normal force, so that way the car doesn't fall through the road, which is probably a good thing. So for the car moving to the right, slowing down, this is what our free body diagram should look like. The arrows always originate on the object and move away from the object itself. Let's look at our next example. Here we have a ball being thrown up in the air. It doesn't matter if it's thrown straight up or up and to the right. The only force that acts on this ball is going to be gravity. Its velocity in the x-plane is going to be constant, so there's no acceleration acting on it. So here, it's just the force of gravity for the ball that's being tossed. For our next example, we're looking for a book at rest on a desk. Since we're on Earth, there's always the force of gravity, and as long as your book does not have enough mass that it collapses the desk, the normal force of the desk should be sufficient to hold the book in place. So you just have gravity acting down, the normal force, the book sitting still. These forces balance each other out. It's in a state of equilibrium. All right, SpaceX, rocket going to Mars. The force of gravity wants to pull this rocket back to the Earth, but the thrust from the propulsion, so you can call this thrust, force of the rocket, whatever you want to call it, is moving us in the positive X or positive Y direction away from Earth. All right, our last example is an elevator accelerating downward. Now here I have two force vectors that are both pointing in the same direction. So ELE. The elevator is also going down. So both of them are going to originate on the dot. You can make your dot a little bit bigger, and you want to have them both pointing straight down. So these are all of our force vectors that we draw on these individual things. So that ends this video.